I wish I was taught this way of finding the greatest common factor when I was in school. It's called the Euclidean algorithm, and here's what it looks like visually. Say we're trying to find the greatest common factor of 8 and 20. What we do is we compare the stacks, take off the difference, throw away one of the equal size stacks, and repeat. Take off the difference, throw away an equal size stack, repeat. Take off the difference, throw away an equal size stack, and repeat. Now, there's no difference, so we're done. So the greatest common factor of 8 and 20 is 4. Now, here's what it looks like on pen and paper, or whiteboard and marker. You always put the larger number on the left and the smaller number on the right. Now, we ask ourselves, how many 8s fit into 20 without going over? Well, 2. 8 times 2 is 16. I need 4 more to make 20. And connecting this to our visual, we were able to take away 8 from 20 twice, and we had 4 left over. Then we compared a stack of 8 to a stack of 4. We always bring the numbers in these two positions down to the next line, and we repeat the process. How many 4s fit into 8? 2, with 0 left over. Now, once we have 0 as a remainder, we're done. The last non-zero remainder is our greatest common factor. So the greatest common factor of 8 and 20 is 4. And we can see this visually. 2 4s fit into 8 evenly with no remainder, so the greatest common factor of 8 and 20 is 4. All right, let's do another one together. Say we're trying to find the greatest common factor of 42 and 120. We write the larger number on the left, smaller number on the right. How many 42s fit into 120? Well, 2. That's 84. 84 plus what equals 120? Well, 36. Then we always bring the numbers in these two positions down to the next line. How many 36s fit into 42? 1, with 6 left over. And we repeat the process. So let's see, how many 6s fit into 36? 6, with 0 left over. Now, since we have 0 as a remainder, we're done. The last non-zero remainder is our greatest common factor. So the greatest common factor of 42 and 120 is 6. Now, a strength of the Euclidean algorithm is that it works really well with large numbers. For example, finding the greatest common factor of 120 and 528 only takes 3 lines. I would much rather do this than list out all of the factors or do factor trees. And by the way, there's another method of finding the greatest common factor that I really like, but it wasn't taught to me in school. That will be for another video.